Welcome to tutorial 1, question number 2. At an upstream location on a river, the flow is 100 cubic meters per second, and at a downstream location, it is 120 meter cubed per second. In 1 hour, the storage in the river reduces by 70,000 cubic meters. If the upstream flow after 1 hour is 120 cubic meters per second, what is the downstream flow after 1 hour? So they're giving us the inflow. Inflow occurs at the upstream of the river, and outflow occurs in the downstream of the river. So inflow is given in the question. At 0th hour, it's 100 meter cubed per second. At 1 hour, it's 120 meter cubed per second. It says 100 at upstream, and if the upstream flow after 1 hour is 120, after 1 hour it's 120. And the outflow, which occurs at the downstream, is 120 initially at 0th hour at a certain instant, and it's Q after 1 hour. This is what we're trying to find. And the question also states that the river reduces by 70,000 cubic meters. So the volume of the river, the storage, the delta storage volume is equal to minus 70,000. It's minus because the river's volume reduces rather than increases. Therefore, the storage volume is negative, and that means in order to solve this question, we have to compare the volumes of inflow and outflow after 1 hour and equal it to the delta volume that's given in 1 hour. So in 1 hour, the volume of inflow is the average, which is 100 plus 120 over 2 meter cubed per second. This is the rate, but in 1 hour, the volume becomes this number times this, because there are 3,600 seconds in 1 hour, minus, this is inflow water volume. The outflow water volume is the average of 120 plus Q over 2 times 3,600, which equals to minus 70,000. Note that this question doesn't state anything about precipitation, evaporation, or any of those variables that are in the water body equation. This is only dealing with the volume, so we will neglect precipitation and evaporation. We will assume they're zero. So we will assume that there is no precipitation and evaporation occurring during that 1 hour. So if we reduce this down, it becomes 110 times 3,600 minus 60 times 216,000. Remember, the minus takes into account of this number and this variable, minus 1,800 Q. If we solve this out, we should get Q is equal to 138.9 meter cubed per second. Now this answer makes sense because the water flowing out is higher than the water flowing in after 1 hour, therefore causing a reduction in the storage volume of the river by 70,000 cubic meters. Pretty straightforward. It's very similar to example 2.1 in the textbook, page 43, I believe. So yeah, let's move on to question number 3.